Alright, please stop me if I talk too fast. This is very similar to yesterday's stuff. Yesterday we talked about similar polygons. Today, similar triangles. First one. Alright, that first top part, what is that called? Can you remember from yesterday? This little piece right here. I don't want to say it out loud because I give away the keyword. This, when it's written like that from yesterday, do you remember what it's called, Allie? Yes, it is a similarity statement. So we've got that similarity statement. I confess all the time, the picture sometimes confuse me because there's so much going on. So if you're going to do the statement proportionality, just use your similarity statement because they have to be in order. So let's start here. Let's put GS is proportional to GN. They're not equal, they're proportional. All right, and then keep going. Make sure you match up all sides. So then ST is proportional to NP. Again, not equal, but proportional. Last ones, make sure you do first and last. GT is proportional to GP. Be very careful. It's really good to get into the habit of making sure all of your numerators come from one triangle. So GS, ST, GT, looks like they're all this big, huge triangle in blue. And then the denominators, GN, check, NP, check, GP. Okay, so it's this little guy. So we're comparing that dark, the blue one, to the purple one. Those are similar. How many made proportionality? I got that. Does that make sense? Be careful. As we're correcting, we notice people putting equal. They're not equal. They're proportional. Their proportions are equal. Okay, this one right here. Yesterday we talked about you have to do two checks. The sides are proportional, but the angles are, do you remember? They're equal. The angles are always equal. They have to be. So if we're looking for GNP, whisper with your neighbor, what do you think GNP equals then? Ready? Go. No? Tell me, what do you think? It is 38. Because see, this is the top corner right there. Top corner is 38. They have to be the same measurement. So angles, kind of nice questions in these. This one is just 38 degrees. Okay, letter C, if you're looking for a piece of the triangle, it's really fantastic if you have the proportionality statement already. So that'll tell you how to set it up. So we're looking for GP. So let's use this. And then what pieces do we know? We know this is 15, NP, ST. So let's use this one. All right, so instead of writing ST, guys, look at the picture. What does ST equal? What's its value? Perfect. So let's put 24 over NP. What's NP? Perfect. Equals, do we know GT? What's GT? Oh, we do. 20. And we don't know GP, so let's put our X there. Okay, grab your calculators. Solve this one. 15 times 20. And then divide it by 24. Is it a whole number, guys? No? Tell me what it is. What is it? Oh, whoa. X equals 12.5. Let me see. How many of you tested it? I got the same thing. Are we okay with this? Wait, perfect. Next example. Okay, this one. This is new. In your notes, will you just triple underline this? And then write it out nicer. There's a postulate called angle-angle similarity. Do you remember the chapter where we did side, 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 angle, side, angle, side, angle, 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 side, all that stuff? It's now on the word wall over there. A crowded word wall if you ever need to look. But now this is similarity. If you know two angles from one triangle are exactly the same as two angles from another triangle, those triangles will have to be similar. Have to be. Now be careful, similar doesn't mean congruent. One's little, one's big. They're similar. Okay, I'm pretty sure the next question has to do with this, angle-angle similarity. So go to the next. Right here. Okay, Allie got this. I want the whole class. What is this called when it looks like that? Yes, it's a similarity statement. So they tell us they're similar, and then they ask to explain why they're similar. Okay, we'll always watch out for these kind of angles. When we first introduced it, I say they come up all year long. So we've got those 90-degree angles in there, but there's another set of angles. Do you know what they are? Jaden, what do you think? Totally. Vertical angles, they're everywhere. So in your books, these two are congruent. Okay, do we have two angles from this triangle? Yep. Check. Do we have two from this triangle? Yep. So why can we say these are similar? There you go. That's what we barely talked about. Angle, angle similarity. And if you don't want to write it out, I am absolutely fine if you use notation. Because of angle-angle similarity, those two triangles are similar. Okay, the next one, that middle question. Oh, there's so much going on with this, and I don't know about you, but when I was your age, I skipped every story problem. Because one, I was lazy. Two, they confused me. So finally, I had a teacher tell me it was okay to cross stuff off. I don't know if you could do that. That sounds dumb, but I really didn't know that. So what we're going to do in this crazy, confusing word problem is just circle stuff we need. First thing, my eyeballs go to this. Circle it. This is going to be our setup. It looks like a super nasty word problem, but turns out they give you everything you need. So find in there, feel free to just skim it. Can you find, they give you A and they give you B. Can you find it? Is it close to the beginning or the end? End, circle it. So we've got A and B, check, check. All right, now they have to give us either H or R. And the one they don't give us, let's just use as X. So can you find H or R? It's in there. Tyler, did you find it? 2.5. H, right here. It's like cut off a little bit. So it starts here. The height H is 2.5. That's it. You're finding this ramp, but let's use that as the proportion. So we're going to do A over B equals H over R. Instead of writing A, they tell you use 1. Instead of B, 12. Instead of H, Tyler found it, 2.5. And then we don't know R. See, it turns out not so bad. It just is like so overwhelming to look at, right? Okay, 2.5 times 12, 30. And then 30 just 5, I went to just straight up 30. 30 inches, feet, meters, what is it? Totally. How many of you agree with me it wasn't too bad after all? Yeah, it's just a matter of finding what we need. Okay, the next question. Okay, this is a really fantastic question. Will you put a box around this? I find that sometimes middle school brains shut down when they see that scale factor. Don't be intimidated by that. If it's a scale factor, you just compare an entire side to an entire side. Now they're comparing this whole triangle to this whole triangle. So we want to do a side and a side. Right here, don't use 12. Use this whole thing. Guys, what's that whole thing worth? Okay. This one, we don't know that anyway, so use this whole side. What is it? Perfect. Okay, to be really nice to yourself, just simplify it. It's friendly if you simplify. What goes into 18 and 30? 6. Right, divided by 6. We'll get 5/3. Okay, now set up a proportion. We're looking for MS, this. So we're going to use 12 and X. But it matters. Are we going to put 12 over X or X over 12? It's going to make a difference. You all got it? 12 over X? How did you know that? Same triangle. You got to make sure. Okay. So scale factor is this. And then solving for MS is the proportion. Okay, guys, you've got this. What's 3 times 12? 36. Yikes. What's 36 divided by 5? 7.2. Okay. So it's one way to solve it. It's not the only way, but that's how you find the scale factor if that comes up. Okay, the next question is a building question, but I want to jump over it and come back because it's the same thing. However, I'm going to stretch you and find scale factor 2. Okay, try it on your own. See if you picked it up just from that one example. Okay, I'm going to push you. Scale factor, compare an entire side to an entire side. So 12 and 12, that'd be 24. 16 and 16, that'd be 32. Because what goes into 24 and 32? The biggest common factor. 8, I'd say that's the biggest. So divide by 8. Scale factor would be 3/4. So if you ever get asked for that, that can be our scale factor. And then use that for your setup. So we're looking for Kn So we've got x and 14. Be careful. Is it 14 over x or x over 14? Totally. X over 14. Good work. Yikes. 14 times 3, then divided by 4. Wait. Is it 10.5? Oh, I got nervous. Okay. 10.5. Final answer. How many of you got 10.5? Sweet. Okay, last one. Building problem. I'm going to leave you to it. Guys, these are so popular for CRTs. So see if you can set this one up before we do it together. I'll show you how you can compare it. Does anybody mind sharing their proportion? This over this, this over this. Abigail, thanks. What'd you do? The scale factor is what? Sure. That's fantastic. That equals 10/3. Okay. Wow, I like that you did that because I think I can do it. 90 times 10. Did you get 300 for your final answer, Abigail? 300 meters? How many of you got the same thing? Oh, that's fantastic. How many of you did what Abigail did? You did? Good work. How many of you did something different? That's totally okay. However your brain sees it, talk yourself through it. You'll be fine.